Alright, so today we're going to be looking at counting cards and also some lottery problems. So we're going to look at 5-card poker. So the book talks about 5-card poker. If you've never played poker, it's not a big deal. The idea is really just that you're getting dealt 5 cards. So it can be any game where you're dealt 5 cards. But in the book they refer to 5-card poker. So when you're dealt 5 cards, remember that there's 52 cards in a deck, okay? And you want to be familiar, in order to do these problems, you kind of need to be familiar with like how many red cards there are, how many black cards, how many face cards. So you may want the image of the entire deck nearby when we go over these problems. Okay? But one thing to notice is that what you're really doing is making a small set from a big set. And let's think about order. Like, if I look at these 2 cards here, I have a king and an ace, and if I reverse those cards, let's get a different color, let's try blue. So let's say if I take the king and the ace and I reverse them, they reverse places, it would still be considered the same hand. The order doesn't matter. Like getting a king and an ace is the same as getting an ace and a king. So we have that order doesn't matter. You can't have repetition, right? Because there's no repetition. You can't have 2 king of hearts. So what happens here is that this is a combination. So whenever we're taking groups of cards, it's going to be a combination. So we're going to use C. Okay. So let's look at some problems here. If it says how many 5-card poker hands are possible, remember that when we use C, we have NCR, and remember that this is the big group, or the number of things in the big group. And from that big group, you're going to pick things and make a smaller group. So the R is the number of things in the small group. So if I were to ask how many 5-card poker hands are possible, well, there's 52 cards in a deck, so the big group is 52. It's a combination because the order doesn't matter. We're making a small group, and the size of the small group is 5. So in your calculator, you would put in 52C5, and you're going to get a big number. This is going to be 2,000, or sorry, way more than that. So 2,598,960. That's how many different 5-card hands there are. So if you think about when people try to win at poker, counting cards, it's a lot more difficult than it looks because there are so many different outcomes. Now, we win more money if we get certain types of hands. Like if we get all of them the same color, that's a good thing. If you get all face cards, that's a good thing. So if I were to say, well, how many 5-card poker hands consisting of all red cards are possible? Okay, so it's still going to be a combination, but you really have to think about your big group and your small group. Okay, so let me think about what my big group is. Last time, my big group was all of the cards, right? And so because it was all of the cards, there were 52 things. But my big group now is all the red cards. And so how many red cards are there? There are 26 red cards. And then my small group is the same. I'm going to take 5 cards. So it's a combination. My big group is 26. That is the red cards. My small group is the 5 cards I pick, so there's 5 cards. This is my small group. Alright, so I put that in the calculator, and I do 26C5 in the calculator, and 26C5 is $65,780. There you go. Look at another one. Alright, so how many 5-card poker hands containing 3 jacks and 2 kings are possible. So notice that this time we have 2 separate groups. We have jacks and kings as well. So I'm going to have a section for jacks and kings. So for this first part, I only get to pick from the jacks. So my big group is jacks. And you have to think about, well, how many jacks are there in a deck? And there's 4 jacks, and we're picking 3. So this one is going to be 4C3, because my big group is 4 jacks. And from those 4 jacks, I'm picking 3. And then for the kings, there's 4 kings. That's my big group. I'm picking 2 of them. And remember, the fundamental counting principle says that we're going to multiply these 2. So if you do in your calculator 4C3, that's going to be 4 times 4C2 is 6. Multiply that together and I get 24. So there are 24 poker hands that contain 3 jacks and 2 kings. That's not very many, given that there's like, what do we say, over 2 million outcomes. The probability that you're going to get 3 jacks and 2 kings is fairly rare. All right, let's look at one more card problem. How many 5-card poker hands containing exactly 3 kings are possible? Now, sometimes the wording of this type of question can be confusing because it says 5 cards, right? So you have to get 5 cards, but then they only talk about 3 kings. When it says exactly 3 kings, you're still picking 5 cards, but 3 have to be kings, and 2 would not be kings, like the rest of them would not be kings. So what this is really saying is 3 kings, 2 non-kings. So what we really want to know is how many 5-card poker hands are possible containing 3 kings and 2 non-kings. All right, so let me write the 3 kings down here. We're going to have to calculate that separately. And then 2 non-kings. All right, so 3 kings. My big group is kings, and you have to think, okay, well, how many kings are there? So that's 4 kings, right? And I'm picking 3, so 4C3. All right, and then 2 non-kings. So everything that's not a king, and how many cards would that be? Should be 48, because there's 48 is my big group, because that's how many non-kings there are, and I'm picking 2. All right, so we have 4C3, which is 4, and let me use my calculator for 48C2. That's 1,128. Multiply those together, and I get 4,512. So there are 4,512 5-card hands that have 3 kings and then 2 non-kings. All right, so let's talk lottery now. So we got cards down. Now we're going to talk about lottery. Okay. So I have here a Super Lotto ticket. And I just want to show you how this would work. So a lot of times when people play lottery, they just do a quick pick, which is where the computer picks for them. But if you have special numbers, you kind of fill in the numbers that you want. So let's say my birthday's on the 17th, so my lucky number is 17, so I'm going to pick in 17. And that's in February, which is the 2nd month, so maybe I pick 2, I bubble that in. I need to pick 5 altogether, so, oh man, they don't have my age here, so I can't pick that. Let's see, I'll go my kid's age. I got a 24-year-old and 26, and I don't know, what's one? I need another lucky number, so what am I feeling good about? Okay, lucky number 40. So I would hand that to the salesperson. They would put that in the machine, and those would be my 5 numbers. And the machine does not know what order I picked them in. So the order doesn't matter. A 2 and a 17 is the same as a 17 and a 2. So again, you could think of this as picking a small group from a big group. With order doesn't matter. So we're going to, again, use C. Okay. Now, Super Lotto actually has another portion where you pick a 6th number from this different set over here. We're going to leave that alone for now. Right now, we're just looking at lotteries where you make one small group from one big group. All right, so let's look at something called a 655 lottery. So a 655 lottery, what that means is that you pick 6 numbers from 1 to 55. And that's including the 1 and the 55 as well. So you pick 6 numbers. So if I were to say, well, how many different, how many different lottery tickets are possible? So we're looking at all the different outcomes. So my big group is the numbers 1 through 55. And we already said we're going to use C. So the big group is 55 because there are 55 numbers. And the small group is 6 because we're picking 6 of them. All right, so I'm going to do, in my calculator, 55 C6. And that is going to be I put a comma in the wrong spot. $28,989,675. So a lot of different possible outcomes. So we haven't talked about probability in this class, but if you bought a single lottery ticket, you would have a 1 out of 28,989,675 chance of winning the lottery. In fact, let's just do that real quick. Why not? We're going to talk about probability in Chapter 3, but just for fun, if I was playing this 655 lottery, I would have a 1 in 28,989,675 chance of winning. I'm going to do that in my calculator. And I get something with a lot of zeros. Let's see, 1, 2, 3, 4, 5, 6, 7. I mean, there's so many zeros I almost can't fit it. So a very, 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 very tiny chance of winning at a lottery like this. Okay. All right, real quick, let's do some classwork. How many different lottery tickets are possible? In a 542 lottery. All right, so I want you guys to pause it, and then I want you to come back and check your answer. All right, so it's a combination. The big group is 42 because there's numbers 1 through 42. We're picking 5, so I'm going to do 42C5 in my calculator. And I get 850,668. So not quite as many outcomes as last time, but still a lot. All right, so that finishes off the counting. Because we did 2.4 part 1, and this is 2.4 part 2. And now you guys should be expert counters, or at least maybe after the homework you'll be expert counters.